In a museum in Istanbul, a small clay tablet sits in a drawer, catalogued as C427, photographed once and largely forgotten for more than 100 years. It was pulled from the ruins of an ancient city in central Iraq in 1894, accessioned, filed, and dismissed as a routine record of land surveying. Nothing more, just another administrative tablet in a collection of thousands. But the tablet is roughly 3,700 years old. It predates the man whose name every schoolchild learns by nearly 1,000 years. And when an Australian mathematician finally examined it properly in 2021, the numbers carved into its surface described a theorem that should not have existed yet. The same theorem still taught today under another man's name. The tablet does not just hint at Pythagoras' work, it uses it, and it signs the work with the name of a woman settling a property dispute. The tablet itself is small enough to hold in a single hand. It is inscribed on both faces in cuneiform, the wedge-shaped script pressed into wet clay with a cut reed, then dried hard in the sun. It was discovered in 1894 during a French archaeological expedition to the ruins of Sippar, an ancient city in what is now central Iraq, about 30 miles south of Baghdad. Once it was pulled from the ground, it was crated, shipped across the Mediterranean, and accessioned into the Istanbul Museum of the Ancient Orient. It was photographed, it was filed, it was shelved, and there it sat, untouched, for 127 years. C307 is not unusual in this respect. It is one of an estimated 500,000 cuneiform tablets currently scattered across the basements of the world's museums, the vast majority of them still unread. The central irony is hard to overstate. The answer to one of the most famous attribution questions in the history of mathematics was sitting on a shelf the entire time, and almost no one bothered to read it. What the tablet actually records, when you finally read it, is not abstract theory. It is something far stranger. It is a receipt. Every schoolchild learns the story. Around 530 BCE, a Greek philosopher named Pythagoras founded a school in the southern Italian colony of Croton, and within that school, he or his followers discovered the relationship between the sides of a right triangle. The square of the longest side equals the sum of the squares of the other two. That single relationship is the foundation of trigonometry. It is the basis of navigation, of architecture, of surveying, of most of the geometry that built the modern world. Pythagoras has been called the father of mathematics. His name has been attached to the theorem for 2,500 years. The textbooks are unambiguous about this. Look in any classroom, in any language, in almost any country, and you will find the same attribution. But the historical record is stranger than the textbooks suggest. Pythagoras himself left no writings. Not a single line in his own hand has ever been found. Everything attributed to him comes from followers writing generations after his death, and there is one detail that those followers all agree on. Before he founded his school, Pythagoras traveled. He spent years studying in Egypt. He spent years studying in Babylon. The Babylon that produced Psi-427 is not the Babylon most people picture. The Hanging Gardens, the towers, the empire of Nebuchadnezzar, all of that came later. The tablet belongs to a much older world. It belongs to the Old Babylonian period, the era of King Hammurabi, roughly 1,800 years before the birth of Christ. This was not a civilization of philosophers. It was a civilization of administrators. Their obsession was record-keeping. Their genius was bureaucracy. Hammurabi's code, the first systematic legal document in human history, was carved on a stone pillar that still stands in the Louvre today. Every transaction in Old Babylonia, every loan, every harvest, every land sale was recorded on clay and stored in archives. Their mathematics did not exist to explore the nature of numbers. It existed to settle arguments over fields, over harvests, over inheritance. They had developed a sophisticated base 60 number system, the same system that still gives us 60 minutes in an hour and 360 degrees in a circle. And their scribes had been using right triangles for the practical division of land for centuries before Pythagoras was born. The question was never whether they knew. The question was whether they wrote it down. Sci 427 answers that question. When Daniel Mansfield finally read the tablet carefully, what he found was a surveyor's document. It describes a specific plot of land that had recently been sold, and a surveyor who was called in to mark the boundary between the new owner's portion and what remained. To draw that boundary correctly, the scribe needed perfectly perpendicular corners. To make perfectly perpendicular corners, he used what we now call Pythagorean triples, sets of 3 whole numbers that always form a right angle when laid out as the sides of a triangle. The most famous is 3, 4, and 5. The tablet used several others. The scribe was not deriving a theorem. He was applying one. He used it the way a modern engineer applies a formula, fluently, without reproving it each time. The mathematics is embedded in the procedure. And then there is the detail that makes the discovery feel real. The tablet names the landowner. A woman, almost certainly wealthy, whose name appears to read Sin-bel-apli. Her dispute involved land that included date palms. The oldest known application of the Pythagorean theorem in human history is, at its core, a receipt, a property line, a piece of paperwork. This raises an obvious question. If the Babylonians had this mathematics in 1800 BCE and Pythagoras was born around 570 BCE, what happened in the 1,000 years between them? The path is not hard to trace. The Old Babylonian Empire collapsed not long after Hammurabi's death, but its mathematical traditions did not vanish with it. They were absorbed by the cultures that followed, copied onto fresh tablets, and taught in scribal schools across Mesopotamia for centuries. The knowledge moved. Egyptian mathematics, recorded in documents like the Rhind Papyrus, shows clear signs of triangular geometry by the time of the Great Pyramids. By the 7th and 6th centuries BCE, Greek travelers were making regular pilgrimages to both Egypt and Babylon to study with the priests and scholars who guarded these older traditions. Pythagoras was one of those travelers. The ancient biographers are not coy about this. Every single one of them mentions his time in the East. And here is the part that needs to be said carefully. This is not a story of theft. What Pythagoras likely did was formalize, prove, and generalize a relationship that had been in working use in the cities he visited for 1,000 years. He gave it a proof. He did not give it its first use. C 427 is not alone. A second tablet, known as Plimpton 322, has been sitting in a collection at Columbia University since the 1920s. It contains a sophisticated table of Pythagorean triples that has been studied by mathematicians for nearly a century. The evidence has been accumulating for decades, and yet most mathematics textbooks, in most languages, in most countries, still teach the theorem under Pythagoras' name with no qualification at all. The natural question is why? Part of the answer is institutional inertia. The name has been attached for so long that unwinding it would require rewriting curricula across the entire world. Part of it is the Western preference for Greek origins in any story about science or philosophy, a preference that has shaped what we call the canon for centuries. And part of it, more honestly, is technical. The Babylonians never wrote a proof. They used the theorem fluently. They did not justify it on the page. For a modern mathematician, that distinction matters. But for the schoolchild told that Pythagoras invented the right triangle, the distinction collapses. The right triangle was not invented in Greece. It was discovered by scribes settling property disputes in the mud of southern Iraq. Return to the tablet, a small clay object, no larger than a hand, sitting in a museum drawer in Istanbul. One of 500,000 still waiting to be read. The woman whose name is carved on its surface, Sin-bel-apli, has been dead for nearly 4,000 years, and yet her property dispute is now the earliest documented use of the most famous theorem in mathematics. She did not know she was making history. She wanted her land measured correctly. The scribe who pressed the wedges into the wet clay did not know he was preserving knowledge that would outlive his civilization by 4 millennia. He was doing his job. The history of human knowledge is not a tidy lineage of named geniuses. It is a long, patient inheritance of working people solving practical problems. And somewhere in a museum basement, the next correction to the textbooks is still sitting on a shelf.